All right, guys, so we're going to go on and get started. So we look at this here. So the first problems, 1 through 3. So these here state the degree and leading coefficient. So one of the biggest things I'll say on the test is make sure to read quickly, is to make sure to read the instructions on the test, because some of them might be put together, especially because when we did the chapter itself, find the degree, determine if it's a or a polynomial function, then state the degree, leading coefficient, so on and so forth. So some of those might be put together, so they're not individual like they are on the review. So for this one here, it just wants us to state the degree and leading coefficient. And if we look at problem number 1, well, we look through the entire thing and see the biggest exponent attached to the variable is not the first term, it's the third one in, which really tells us that the degree is 8, and the leading coefficient, which is the number in front of the variable with the biggest exponent, is going to be negative 27. So for the first one, the degree is 8, and the leading coefficient is negative 27. We can do the same thing for the next one, and if we look through this one here, well, it turns out the variable with the biggest exponent is the first one. So it tells us our degree is 4, and the leading coefficient is 6. And that's all we have to do for that there. The next one is the exact same, but again, just like with the first one, the first term isn't the one we'll look at. We'll end up looking at almost the last term, which is telling us that the degree is 7 and the leading coefficient is negative 27. Questions on 1 through 3? Four through 7, we want to evaluate it for the given value. Now, we've come across several different ways to evaluate. One of them is using synthetic division, because the remainder that we get with synthetic division is the same as plugging it in. Or we can plug it into the calculator. Now, it doesn't matter which one we use, so you can use the 30XS or the 84s. Either one works. And all we're doing is plugging in the given value. So for the first one, it is negative 4. So we have 3 times negative 4 to the 4th, plus 2 times negative 4 to the 3rd, minus 12 times negative 4, minus 6. And we get negative 854. And that's the answer. Now, we could have stored it. We could have said negative 4 store. Let's see here. X is, here it is, X. And then said negative 3x to the 4th plus 2x to the 3rd minus 12x minus 6. And we get the same answer. And we can store it in the 84s as well. Negative 854. Questions on 4? Questions on 5, 6, or 7? Because for any of these here, you're just plugging it in. So we can do the same thing with the next one. Negative 7 cubed plus 3 times negative 7 squared plus 5 times negative 7 plus 1. And if we type this in, we should get 162. Questions on these here? Okay. Okay. So do we need to see another example of 6 or 7 or how these work?
5, I thought it was 456.
Let's see here. Yeah. So 5, let's go on and double check it just to make sure. I'm on the right page. Because I probably typed something in different this morning. 7 to the third plus 3 times negative 7 squared plus 5 times negative 7 plus 1. 456, yes, that's right. Any other questions on 6 or 7? Questions on 6 or 7? Yeah. Because if we wanted to, with synthetic division, either one of these are going to be nice. Oh, okay. Because, I mean, with number 6, we could say 8, 1, 0 for x to the 5th, negative 64 for x to the 4th, 0 for x cubed, 1 for x squared, negative 7, negative 51. So we can do 1 times 8 is 8, plus 8, 64, 0, 0, 0, 8 times 0 is 0, 1, 8, negative, not negative 1, that'd be positive 1, which would give us 8, which is negative, because, yeah, negative 43. Because doing it with synthetic division, the remainder will give us what it's equal to if we plug the value in. So you don't have to do it by synthetic division. You can just plug it into the calculator. Either way does work. Questions on any of this here? Now the next 3, determine if the following function is a polynomial. So for number 8, well, with this here, there was a list that we had kind of when we went over this the first time that really helps us determine if they are or not. Well, the exponents can't be negative, fractions, or have a variable. Variables aren't inside radicals. Variables aren't multiplied together, and variables can't be in the bottom of a fraction. These 6 are really the ones we're looking for, because if it has one of these 6, then it's not considered a polynomial function. So if we look back at these first few, so number 8, is it a polynomial function? No, because we have x to the negative 1. It doesn't work. That's one of the ones we listed off. If we look at number 9, all the exponents, none of them are fractional, negative, or have a variable, so they're good there. We don't have any fractions, so we don't have to worry about that. There are no radicals, and we don't have 2 different variables being multiplied together. So is it a polynomial function? Yes. Number 10. No. We have a fractional exponent. So on the test, some of these might be combined, determine if it's a polynomial function, stating degree, leading coefficient. Some of those might be grouped together. So just read the instructions to see what it's asking. Any questions on this here? So 11 through 19, we just want to simplify. Whenever we're adding two expressions, we're really just combining like terms. So 3x squared minus 2x squared is just going to be x squared. 4x minus 3x is going to be plus x. Negative 1 plus 2 is plus 1. Because when we're adding and subtracting, we're just combining like terms. Because since they're added together, it's plus, we don't have to worry about a sign change. Same thing's true for the next one. Because I could look at this here and see 12x to the fifth is here. Do we have any x to the fifth in our other one? No, so we have 12x to the fifth. At 3x to the fourth, 8x to the fourth. So negative 3 plus 8 is going to be plus 5x to the fourth. Well, the next power would be cubed. I don't have any here. But we do have a negative 3x cubed in the other one. So it's just minus 3x cubed. I don't have an x squared term in the first, and I don't have one in the second, so there is no x squared. Then we have what next? 2x plus 4x is. And lastly, negative 5 plus 1 is minus 4. If you wanted to rewrite this out and had all the like terms next to each other and then combined them, that works just as well. Any questions on 11 and 12? Let's look at 13. Now 13 is a little bit different because it is subtraction. And we do need to be careful with subtraction because everything in here, we have to apply the negative to it. So we have negative 2x to the fourth. Negative times 3x cubed is going to be negative 3x cubed. Negative times negative x squared is going to be plus x squared. Negative times x is minus x. And negative times negative 4 is going to be plus 4. It's going to change the sign. So we have to apply that negative to everything in the second one. Now we can combine our like terms. 7x to the fourth minus 2x to the fourth is 5x to the fourth. Our next one is thirds. Negative 9x cubed minus 3x cubed is negative 12x cubed. Negative 4x squared plus x squared is negative 3x squared. 5x minus x is going to be plus 4x. And lastly, plus 6 plus 4 is plus 10. And that's it. Questions on this so far? But the real one with this here is just making sure we distribute that negative so that we have the correct sign. Distribute the negative, combine like terms. Any other questions on 13? We ready for 14? If we look at 14, we're doing essentially the same thing. 11x to the fourth minus 9x squared plus 3x plus 11. We have to distribute that negative, which gives us negative 2x to the fourth. Minus 6x cubed minus 2x plus 9. Essentially, we're changing the signs from positive to negative or negative to positive. We're flipping it from one side to the other. And then we're going to be combining like terms. Negative 11x to the fourth minus 2x to the fourth is 9x to the fourth. In our first one, we don't have cubes, but I do have a 6x to the third, yes? So it's going to be minus 6x to the third. Here I have an x squared. Do we have any other x squareds? No. So we have minus 9x squared. 3x minus 2x is plus x. And lastly, 11 plus 9 is plus 20. And whenever I'm combining like terms, I'm just going in order. So the biggest one we had was x to the fourth. So I'm looking at x to the fourth, then x to the third, x squared, x constant. And I do it in that order just to make sure I do have them all in order. And as you see here, I do kind of put something underneath it so I know that I've taken them into account. So we put them all together. Questions on this here? Any questions on any of this so far? Let's look at the next one, 15. Distributed property, we're multiplying these out. We only have one term, so we're just multiplying through. So we'll do 6x times 6x cubed times 2x squared. Well, 6 times 2 is 12. X to the third times x squared would be x to the fifth. When bases are the same, we add the exponents. And we do the next one, 6x cubed times negative 27x. Well, it's going to be negative. Well, we can do, because it's 27 times 6, 162. 162, and it's going to be x to the fourth. And lastly, 6x cubed times 4. It's going to be plus 6 and 6 is 12. 12 and 12 is 24. X cubed. And that's it. Questions on this here? We're going to do the exact same thing for 16. So we'll start off with 2x. 2x times 2x squared is 4x cubed. 2x times 5x is going to be plus 10x squared. And 2x times 8 is plus 16x. Then we do the same thing with 4. 4 times 2x squared is going to be plus 8x squared. 4 times 5x is plus 10x, and 4 times 8 is plus 32. Now, if you do like the way that I add these together like this here, do make sure that you line up the like terms. So here, when we do add, we just add straight down 4x cubed plus 18x squared plus 26x plus 32. Because if you line them up incorrectly and you're just working through it quickly, you'll add unlike terms together. So I like to put the like terms over the top of each other. Questions on this here? Questions on any of this so far? Are you ready for the next one? So again, this one here, we're doing the exact same thing. So the first thing we can do is multiply through by 3x cubed. 3x cubed times x squared is going to be 3x to the fifth. 3x cubed times negative 2x is going to be negative 6x to the fourth. And 3x cubed times 1 is going to be plus 3x cubed. So we multiplied through by 3x cubed, and we got this here. We good with that so far? Now the next thing we can do is multiply through by negative 9x. So what's negative 9x times x squared? Well, it's going to be negative 9x to the third. I wouldn't put it under the negative 6, x to the fourth. We're going to put it under here. Because I'm going to keep the like terms lined up. Negative 9x times negative 2x is going to be plus 18x squared. And negative 9x times 1 is negative 9x. Because doing some of the multiplications wouldn't be too bad, but x times x squared is x cubed. We can line those up and then simplify the rest. And lastly, 7 times x squared, well, that's going to be plus 7x squared. 7 times negative 2x is negative 14x. And 7 times 1 is plus 7. Well, 3x to the 5th and 6x to the 4th are going to come straight down. They're no like terms. 3x cubed minus 9x cubed is going to be negative 6x cubed. 18x squared plus 7x squared is plus 25x squared. Negative 9x minus 14x is negative 23x plus 7. This one here was a little different than most because we normally do have some terms that do line up in most of these here. There we go. But normally the only terms that don't really have common factors are the biggest one and the constant term. Those are normally going to be by themselves. Any questions on this here? 18 and 19 really aren't any different. It's just that we've got to do it more than once. And it doesn't matter which ones we pick. So I could do these two here first. We can do 4 times 1, which is 4. 4 times negative 2x is negative 8x. Negative 5x times 1 is negative 5x. And 5x times negative 5x times negative 2x is going to be plus 10x squared. So we distribute the first one through. Just like we've been doing on the last few, same thing here. The next thing we would do is combine like terms. I'm going to flip the order of the first one because I want to write it in standard form, the variable with the biggest exponent first, and then decreasing order. And lastly, we can go on and distribute through here. 10x squared times 3x is going to be 30x cubed. 10x squared times 2 is plus 20x squared. Negative 13x times 3x is going to be negative 39x squared. Negative 13x times 2 is minus 26x. 4 times 3x is plus 12x. And 4 times 2 is plus 8. So we get 30x cubed minus 19x squared minus 14x plus 8. Any questions on any of these here? Any questions on any of these so far? Do we need to see 19? Because 19 and 18 are going to be the exact same. We ready for the next set? Okay. For the following polynomials, divide the two polynomials by synthetic or long division. I think for most of these here, y'all like synthetic division more than long division. And with synthetic division, we have to take this here and set it equal to 0, which is going to be to add 5, telling us x is 5. So the number that goes in the cubbyhole here is 5. The numbers going across the top are 1, negative 10, 20, and 26. And this is really also telling us if it is a solution, because if the remainder is 0, then that value is a solution of the polynomial function, yes? And all the polynomial functions will have a rational 0. Dealing with this here was one of the factors, because our P over Q is 5 a factor of 26. Is 5 going to 26 evenly? No, so most likely is 5 going to be a solution? No, so our remainder should not be 0, most likely. And if we solve this here, 5 times 1 is 5. Negative 10 plus 5 is negative 5. 5 times negative 5 is negative 25. 20 plus negative 25 is negative 5. 5 times negative 5 is, and 26 plus negative 25 is 1. Now 1 is our remainder. The number next to it, that negative 5, is our constant term, our term without x. The one next to it is our term with x. And then we have the term with x squared. So our solution here is x squared minus 5x minus 5 plus 1 over x minus 5. So that there is our solution. And kind of with the rational zeros, because it's not a factor of 26, it's probably not going to be a solution. Which means we'll have a value different than 0 for the remainder. Questions on 20? Do we want to look at 21 or 22? So we'll do the same thing here. We'll have the cubbyhole in line dealing with synthetic division. And the first thing we can do is set x minus 1 equal to 0 and solve, which tells us x is equal to 1, yes? And we'll put it in the cubbyhole. The number's across the top, so we'll have 7 for x to the 4th, negative 10 for x cubed, 3 for x squared, 3 for x, and negative 3. Now remember, if there is a term missing, so since we had x to the 4th, we need the 3rd, 2nd, squared, 1st, and constant. If one of those is not there, we have to put it back in as 0. Now we can go on and do this here. 1 times 7 is 7. Negative 10 plus 7 is negative 3. 1 times negative 3 is negative 3. 3 plus negative 3 is 0. 1 times 0 is 0. 3 plus 0 is 3. 1 times 3 is, which gives us 0. So that tells us we have a remainder of 0. The 3 next to it is our term without x, our constant term. The 0 next to it is the term with x. The negative 3 is the term with x squared. And 7 is the term with x cubed. So we have 7x cubed minus 3x squared. We don't have to include the 0x, but we have plus 3. So that there is our solution. Questions on this here? We'll see how far we get through today. We good with this one here? Let's look at the next one. So this here, when we have these polynomial divisors, so here we're dividing by x squared plus 4x minus 2. It might be a little bit easier to do this with long division. We'll put the 2x to the 4th plus 8x cubed minus 5x squared minus 4x plus 2. Inside we'll have the x squared plus 4x minus 2 on the outside. And we'll get this set up here. Now the first main question is what times x squared gives us 2x to the 4th? Well, that's going to be 2x squared. And we'll multiply it off to the side. 2x squared times x squared plus 4x minus 2. And when we distribute this here, 2x squared times x squared is 2x to the 4th, which does match up. 2x squared times 4x is going to be plus 8x cubed. And 2x squared times negative 2 is negative 4x squared. So we have 2x to the 4th plus 8x cubed minus 4x squared. and then we subtract. 2x to the fourth minus 2x to the fourth is 0. That's exactly what we wanted to happen because we want that first term to always cancel out, be 0. Let's look at the next one, 8x cubed minus 8x cubed. Well, that is actually 0 as well, yes? And it can work out this way sometimes. And we look at the next one, negative 5x squared minus negative 4x squared. Well, the negative and negative does make a positive. Negative 5x squared plus 4x squared is negative x squared. We bring down the next term, yes? How many terms do I have over here? 3, yes? How many terms do we have currently underneath? 2, yes? But we need, so we'll bring down the plus 2. Because we could go through and have left the 0x cubed and then say the next one is times 0x squared, but that's not really giving us anything. So the next part here, what times x squared is negative x squared? Because we already have the squared, don't we? So we just need what? Negative 1. So we can multiply the whole thing by negative 1. And if we do that, we would get negative 1 times x squared is negative x squared. Negative 1 times 4x is negative 4x. And negative 1 times negative 2 is going to be plus 2. So we get negative x squared minus 4x plus 2. And we're going to subtract. Well, negative x squared minus negative x squared, well, the negative and negative make a plus. Negative x squared plus x squared is 0. Negative 4x minus negative 4x. Negative make a plus, so negative 4x plus 4x is 0. And lastly, 2 minus 2 is 0. So the remainder here is, so this here is our solution, which tells us the solution is 2x squared minus 1. Questions on this here? Be ready for the next one. All right, find all the rational zeros. So our rational zeros come in the form of plus or minus p over q, where p are the factors of the constant term, and q are the factors of the leading coefficient. So for our constant term, we're looking at the factors at 27. So we'll have 1 and 27. 2 doesn't work, 3 does, 3 and 9. 4 doesn't work because it's 4 and 6 point something. 5 doesn't work, and that's it. So those are all the factors of p. Factors of q, so factors of 9. So we have 1 and 9 or 3 and 3. But we're not going to repeat any factors, so we're not going to list 3 twice. We're only going to list it once. Now for this here, we're always going to have all the factors of p as solutions because we do p divided by q. Well, 1 divided by 1 is 1. 3 divided by 1 is 3. 9 divided by 1 is 9, and 27 divided by 1 is 27. So we could go on and list out all the factors of p to take care of the case where q is 1. Then we can move over to 3. So we have 1 divided by 3, which will be plus or minus 1/3. 3 divided by 3 is 1. We already have it. 9 divided by 3 is 3. We already have it. 27 divided by 3 is 9. So the only one that added was 1/3. We can move over to the last one. 1 divided by 9 is 1/9. 3 over 9 is 1/3. We have it already. 9 divided by 9, 1. 27 divided by 9 is those are all of our factors. And that's it. And it's easier if you go each value of q one at a time like we did here, so that we know when we have the repeated terms. Any questions on this here? We can go on and look at 26. So here, plus or minus p over q. Well, p here is going to be the factors of 15. So we'll have 1 and 15, 3 and 5. Q is going to be 1 and 12, 2 and 6, 3 and 4. And again, we can go on and list off all the factors of p because they're being divided by 1 first. So plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. Because that's going to be an easy place to start. Because they're just going to give us the numbers back. The next one we can do is 2. So we'll have 1 divided by 2, which is going to be plus or minus 1/2. 3 divided by 2 is going to be plus or minus 3/2. 5 divided by 2 is going to be plus or minus 5/2. And lastly, 15 divided by 2 is going to be plus or minus 15/2. Because if they don't have a like term or a common factor, we're going to end up listing them all out. Then we can move on to 3. So we can say 1 divided by 3, 1/3. Then 3 divided by 3 is 1, 3/3, or 1. Then we can have, which is already there, then we do 5 divided by 3 is 5/3. And lastly, 15 divided by 3 is 5. We already have it, so we don't need to list it again. Then we can move on to 4. 1 divided by 4 is going to be our 1/4. 3 divided by 4 is 3/4. 5 divided by 4 is, and lastly, 15 divided by 4 is 15/4. None of those repeated. Then we can move on to 6. 1 divided by 6 is going to be plus or minus 1/6. 3 divided by 6 is 1/2. Because you can plug these in a calculator, 3 over 6, and see what we get. 1/2, we already have it. 5 divided by 6 is just going to be 5/6. And lastly, 15 divided by 6 is 5/2. We have it, so we don't have to list it again. Let's do this color here. So we can do 12 next. Do this color instead. That's a little better. So we can say 1 over divided by 12, which is 1/12. 3 over 12 is 1/4. We have it already. 5 divided by 12. 5/12, so it doesn't reduce. And lastly, 15 divided by 12 is, because they both have a common factor of 3, so it'd be 5/4. And we have 5/4. So all of these here are the factors. Questions on any of this here?
How did we get the numbers?
Factors of the leading coefficient.
Okay, so P is what?
Factors of the constant term.
And then Q is the coefficient.
Factors of the leading coefficient, yes. Questions on this here? Any questions on any of this here? 27, Descartes' rule of signs. Find all the possible positive, negative, and complex solutions. So for positive, we're just counting the number of sign changes of the function that's given to us. X to the fifth to x to the fourth is 1. From the fourth to the third, that is 2. Third to squared is 3. Squared to x, it doesn't change. And from x to our constant term, it does. So the most positive terms we can have is 4. Because we just go on and count it from the beginning. For the negatives, so we're plugging negative x into each spot where there is an x. And as we observed when we went over this first time, if the power is odd, the sign will change. If the power is even, it stays the same. So for our first one here, the power is odd, so it goes from positive to negative. The next one is even because it's a 4, so the sign stays the same. The next one is odd, so it changes from positive to negative. The next one is even, so it stays the same. The next one is odd because it's really to the first power, so it changes to positive. And our constant term is not affected because it doesn't have an x. It doesn't have a variable. And again, we count the number of sign changes from term to term. From the fifth to the fourth, negative, negative, no. Fourth to the third, no. Third to the second, no. Second to the first, yes. And from the first to our constant, so the most negative solutions we can have is 1. Okay. Now, how many solutions should we have for this here? 5, yes? So the most positive we can have is 4. The most negatives we can have is 1. 4 and 1 gives a total of 5, yes? So are they all accounted for? So it'll be 0 complex. Now, as we said for this here, we can have either one of these numbers or an even number less than it. Now I start with negatives. Can we subtract 2 from 1? No. I mean, we can, but we get a negative. We can't have a negative amount of zeros. So I don't subtract it from here. I'm going to subtract it from the positives if I can. 4 minus 2 is 2. And this wouldn't be 0. It'd be 2. So I'd watch that because it's very easy to just keep writing 0 for our complex. Because again, we still need this to equal a total of 5. Now again, we still can't take 2 away from the negatives. So this is still going to be 1, but I can take it away from the positives. 2 minus 2 is 0. So I could have 0 positive, 1 negative, and 4 complex. So those are our zeros there. Questions on this here?